Today we will take a look into microkernel architecture style. This is also the part of monolithic patterns or monolithic architecture styles, as is for layered architecture, as for pipeline, and now we continue with microkernel architecture style. One of the key features of this architecture style is that it allows us a quite good range of customization if we will compare with previous architectural styles. What is the topology of microkernel architecture style? So the microkernel architecture style is a relatively simple monolith architecture consisting of two architectural components. The first is the core system, which is on the middle on this image. And the second one is the plugin components that can be plugged in to the core system. Application logic is divided between independent plugin components and the basic core system, providing extensibility, adaptability, and isolation of application features and custom processing logic. What else we can tell about the microkernel architecture? First of all, let's take a look into their core system. The core system is formally defined as a minimal functionality required to run the system. So what should you put inside the core of the system? Something that where you are sure that this part will not change. The basic logic, the basic pipeline of functionality, basic things. They should be in the core system. The core system is the happy path through the application. General idea. For example, if you want to, let's say, if you want to build a system which will, one of my favorites, migrate the data from one source to another one source. Each of the data can be migrated in a different way. Some of the algorithms, some of the approaches can be applied for different kind of dates. But what is the main idea in this application? What will not be changed? The basic things that will not be changed, that you will take the data from one source and you will put the data to another one source. And this part should be inside of the core of the system, the basic functionality for which you are designing the system, why you are developing, what the business thinks it will resolve. All other stuff, how you will manage the technically specific things for specific fields and so on in this particular task, it can be put it into the components, and you can plug in each of them. Depends on what kind of data you are working with. So there should be in core system the little part that there is that will have the happy path even without any custom processing, any customization. Which what it will provide us, what kind of opportunities it will give. First, it will bring us better extensibility and better maintainability, and also as increasing testability. Keep in mind this when you will choose one of the architectural styles. Depends on the quality attribute, depends on the architectural characteristics. So depending on that architectural characteristics, if you will decide it based on working with stakeholders that in particular in your project, the extensibility and the maintainability is more preferable, they have high priority than other quality attributes, then in this case, maybe it makes sense to choose this one approach. What should be inside of the core of the system? As you can see, there is different variants of microkernel architecture core system. Here on the image, you can see that it contains, for example, it is like a part of layered architecture. Here we see that core system just wrap the layer architecture. It consists persistence layer, business layer, presentation layer. Does it mean that only such layers can be inside of the kernel, inside of the core system of microkernel architecture? No, it doesn't. So depending on the size and complexity, the core system can be implemented as a layered architecture, or it can be as a modular monolith. In some cases, the core system can be split into separate deployed domain services, which with each domain service containing specific plugin components specific to the format. Here it is. So one more time, depending on the size and the complexity of core system, the core system can be implemented as a layered architecture or modular. And here you can see that instead of layers, we can use, for example, domain-specific components. This is also microkernel architecture, and it also apply for the core of the system. For example, it can be like payment component or delivery component or order component. Don't mix it with other architectural styles. It still is microkernel architecture style. Now we will talk about the plugins, but before we will switch for the plugins, let me tell you one more thing, that even let's switch here. Yeah, you can see here that the presentation layer is as a part of the core system. So we have presentation layer, business layer, and persistence layer. The presentation layer of the core system can be embedded with the core system or implemented as a separate user interface. So it means that with this approach, you can add here in another one box on the top of core system and call it, for example, user interface. And this user interface can be as an embedded part. What it means embedded part? It means it will be as a single deployment unit. So you will deliver your solution with front end will be, or user interface will be embedded into their single delivery unit. And so it means single deploy will deploy the backend and front end. It can be, as well as user interface can be splitted, and it will looks like we will have separate front end and backend side that is more frequently, and you can still and you can see such approaches on practice. So it means if the user interface will be splitted from the core system as a separate user unit, so you will deliver multiple deployment units, and multiple deployment units will be delivered to the customer. Also, even you can split presentation layer as a user interface core system, and also add here plugins to the user interface component. So it means in this case, it's still possible to design the system in the way that you will use such approach not only for the backend side, where there will be the business logic with plugin component that can be plugins, exactly as they names, but as well, it means that you can put some functionality in a separate deployment unit and use plugins component as a front-end part. And so you will choose the same architectural styles now for backend and for front-end, and all of them together, they will present you the single architectural styles, which we'll call microkernel architecture styles. One more comment before we will switch to the plugins and how they looks like. Is it or how frequently you can faced with such style on a projects. And nowadays, one of the most popular is microservices, and there were a lot of topics, discussion, workshops, and specifically since maybe last 5 years, that or maybe last 7 years, that this is the better way to do everything, and you can face that it is applied in different areas. Comparing with microkernel is not so popular, is not so famous, but it looks like in many cases it is much more suitable, and it's much more better to apply this architecture approach instead of microservice approach. We'll take a look into microservice later on, but keep in mind this. Specifically, it can be useful and can be much more better choice without quite less issues in future if you will choose specifically this one. What about plugin? What it is? So plugin component are standalone independent component that contains specialized processing, additional features, and custom code mean to exchange or extend the core system. So additionally, they can be used to isolate higher volatile code or creating better maintainability and stability within the application. Yeah, and ideally it should be independent of each other and have no dependency between them. So try to figure out it specifically in this way. The communication between plugin components and the core system is generally point-to-point communication. So it means it's usually method invocation or functional call to the entry point class of the plugin component. So if you will do this communication in this way, that it will be point-to-point communication, just direct invocation of some methods or so on, then for sure it will works much more faster comparing with other approaches. I'm sorry, just 1 second, please. So yeah, I'm so sorry on unpredictable things. So this is the best way to implement it. Let me try to provide you some practical examples or explanation how it can look like. Let's say that you will build the basic pipeline using the core system, and you will put it into as a core part. And for example, these components, it will be some part of code that all of them will implement the interface, a single interface with once or several methods, let's say. So this interface will bring the contract to the implementation, and the core system will know about this interface. As you know, the method invocation is executed. The method is executed by the reference type, not by the instance type itself. So it means and we keep in mind that about their extensibility, about the polymorphism abilities of modern object-oriented languages. So it means that here in the core system, you can try to get access, you can try to execute the method by the reference or from the interface, but depending on which kind of instance will implement this interface, then this method will invoke. So in one way, if you will put the instance of this component, instance of this class, then methods from this class will be executed. In other cases, if we will meet and find the instance from another one class, then method from this component will be executed. From this, or so on. So it means you will build a quite strong and simple solution That means that if you will need to bring new functionality, everything that you need is just to plug in new component with new logic that will be implemented by inside of this method from the interface that can take some parameters from the core system, apply some actions, and return back the result that will cover the contract by the interface. This is one of the example and how you can implement it using the plugin components with direct communication, let's say like point-to-point communication. So runtime plugin components can be added or removed at runtime without having to redeploy the core system or other plugins. It depends from the technology stack that you will use. For example, it can be using the Open Service Gateway, or it can be for the Java, it can be Jigsaw. For the .NET, it can be Prism use when you will just plug in some functionality even without redeploying. This is one of the key feature that should make the things much more easily and to live with. So it means that it's really the benefit. Also, point-to-point plugin components can be implemented as shared libraries. So you can put some, let's say, Java code into the package or namespace in C#. And so this component, it can be itself the shared libraries. And you will just plug in the implemented jar or DDL or let's say in Ruby gem files for this core system. Also, plugin components do not always have to be point-to-point communication with the core system. And it still will be the microkernel pattern or architectural styles. So another way is that you will include using the REST or messaging as a means to invoke plugin functionality with each plugin being a standalone service. So it's still possible that all of them will be standalone units. So all of them will be deployed separately. And communication between, let's say, even it can be like a services. You will have here like single service, here another one service. Communication with them will be through the REST, but still it will be microkernel approach. It will not be microservice approach or service unit, something like this, because you will just plug in some functionality. Is it the better way to do? There is pros and cons from this way. If you will need to change some of the components, maybe it will be more easily if we are not talking about, as just talked before, about the Jigsaw in Java or Prism in .NET, where you can plug in without redeployment on all unit. Here in this way, you will need to redeploy one of the instances, but still it can be more easily than the redeploying everything from one point of view. But from another point of view, communication through the REST, it will take much more time and you will use in performance for sure. So with the performance, with another quality attribute also. So yeah, keep in mind this point. What else? So there is a trade-off actually. There is a trade-off between what? Remote plugin access turn the microkernel architecture in a distributed architecture rather than a monolithic one. So actually it will look like distributed more than the monolith. So it will make it difficult to implement and deploy for most third-party or on-premise products, where it will be better to deliver everything in a single unit. In most on-premise projects, they prefer in this way. So it creates more overall complexity and cost and complicated the overall deployment topology as well. If one of the component is not working, then it's not possible to complete the request. The request cannot be completed in this case. So and so on. So there is cons and pros from this one. Also, just pay attention that, for example, even if all of them will be as a single deployment unit, all these components, each of them, it's still possible that it's hard to imagine the reason why should do, and my personal opinion that you should avoid, but it's still possible that all of them can have separate database connection. So, for example, each of these plugin components can be connected with separate databases. So, and core system will have a separate database. So keep in mind that it actually can be. What kind of yeah, now let's take a look for architectural characteristics of microkernel architecture. As you can see, general, it is a little bit more better than if we will compare with monolithic, but okay, let's take a look, for example, for the overall cost. Overall cost is quite good. It's similar to the layered architecture style. Simplicity and overall cost are the main strong things of the microkernel architecture. The cost is the same. Simplicity is a little bit less because it less stars. It means simplicity is higher. It means it will be implemented as simple as with a layered approach. It is a little bit more complex. But still, if we will take a look for example, testability, deployability, and reliability, the rate is a little bit more above average. So testability, deployability, reliability is like not so bad. Modularity and extensibility, it also rates a little above average, so it's more preferable to choose microkernel architecture comparing with layered architecture or pipe and filter architecture if in case of modularity, extensibility is more preferable choice as a quality attributes, what do you want to achieve, or non-functional requirements or architectural characteristics, whenever you will call the point is the same. So trade-off between these architectural characteristics, it means that in this case, microkernel maybe it's better way to choose than layered. The microkernel architecture style is unique in that it is only architecture style that can be both domain partitioned and technically partitioned. So yeah. Performance is always an interesting characteristic to rate with microkernel architecture style, and you can see that performance have 3 rates here, something above average. So there is like some, it depends actually in which way you will implement it. If the communication will be direct point-to-point, then performance will be significantly better than REST communications. What is the conclusion about the microkernel architecture? So we can see here, if we will compare with layered.
Вибачте, залишилось 2 хвилини.
Yeah, thanks a lot. So if we will compare with layered architecture and pipe and filter, that this one is more that it is the cost almost the same, but simplicity is less. But from the other side, it will bring us better testability, deployability, modularity, extensibility, specifically modularity and extensibility. So if that architecture characteristic has higher priority, then your choice is this one. And as for me, as my personal opinion, this is one of the top architectural styles. Quite good choice. So then, thanks for the attention, and next will be another architectural styles after the quick break.